Good afternoon once again. Welcome to my subject logic circuits and switching theory. Now, this will be our second session, our lecture 2 of our subject. So, first, let's proceed with conversion. So, I hope you already passed your assignment as of this time. Okay, so let's start with conversion, but from base 10 to base n. So let's start with the integer part or the whole number. So to convert from base 10 to base n, so you have to divide the number in decimal to n. Take note of remainder. Then continue dividing the integer by n until the integer number is reduced to less than n. So example, so let's have 13 base 10. Please convert it to base 2. So the decimal 13 to base 2, so you have to divide it by the base number you wanted to convert. So this time you wanted to convert to base 2, so your divisor would become 2. So 13 divided by 2, so you have to take note of the remainder. So 13 divided by 2 is 6, but it has remainder 1. So you have to write the remainder 1 here. And then continue. 6 divided by 2 is 3 with remainder 0. Okay. Then continue. 3 divided by 2, so we have 1 with remainder 1. So take note that 1 is already less than the, it's already a fractional part, so we just simply write down 1 here. Okay. And then read upwards, so it would become 1101. Therefore, 13 base 10 is 1101 base 2. And then example 2, so we have convert 57 base 10 to base 5. Okay. So how we're going to do that? So to convert base 10 to base 5, so you have to divide the decimal number into 5, because you wanted to convert it to base 5. Then take note of the remainder. So we have 57 divided by 5 is 11. 11 with the remainder 2. 11 divided by 5 is 1. 11 divided by 5 is 2 rather, with the remainder 1. Then 2 over 5 is already less than, then take note of 2, because it is already less than the base number, or what do you call this, divisor number. Okay. So if this less than 1 or less than the divisor, so you already need to copy. Just copy. So therefore we have, then read upwards, so it becomes 57 base 10 therefore is equal to 2 1 2 base 5. So we have it right here. Okay. The next we have example number 3 is 89 base 10. 18 decimal 89, convert it to base 8. Okay. So again, divide the decimal base 10 into the base number you want it to convert to. So this time we'd like to convert it to base n, so our divisor would be 8. Okay. So 89 divided by 8 is 11 with remainder 1. Then 11 divided by 8 is 1 with remainder 3. Since 1 over 8 is already less than 1, so you just simply copy 1 here and then read upwards. So it's actually 1 3 1. So therefore 57 base 10 is actually equal to 131 base 8. And last we have convert 123 base 10 to base 12. So again we divide 1 to decimal 123 to base number that we want to convert it with. So this time we wanted to convert to base 12. Okay, so let's start. So 123 divided by 12 is 10 with remainder 3. So since 10 over 12 is already less than 1, so we just simply copy 10 here. But in base 12, 10 is actually after 9, so the valid symbols for 12 are 0 to 9, then A, B. So the 10 over 10 is actually A. So you have instead of writing 10, you have to write A. So therefore, 57 base 10 is A3 12, base 12. Okay? Any question? So, any question, clarification, please PM me. Okay. I know this is already a review for you. You have this from your previous subject, computer fundamentals. So, this is just a sort of review for you. Okay? So, this is just a refresher. Now we're done with the integer part or the whole number part. So let's proceed with the fractional part or the decimal part. Okay. So to convert the fractional part in base 10 to base n, the number should be multiplied to n. Take note of integer part. Keep on multiplying the fractional part by n, then read the integer part downward. So example here, convert 0.82 base 10 to base 6. So what will you do? So instead of dividing, we multiply it to the base number we'd like it to be converted to. So this time we'd like it to convert to base 6, so therefore we multiply it to base 6. So 0.82 times base 6. But this time, so for fractional part, instead of taking note of the remainder, you have to take note of the integer of the whole number. So if we're going to multiply 0.82 times 6, so the answer would be 4.92. But you have to take note of the integer. Okay? So the integer or the whole number is 4, and then continue multiplying the decimal part. So we have 0.92 here. And then the 0.92, you multiply it again by 6. And then you shall have an answer of 5.52. 5.52. Okay, so let's take a look. Let's have a calculator here. Let's have a confirmation. Okay. Okay, so again. Okay, so we have 0.82 times 6. So the answer is 4.92. But you write the whole number here, and then you continue multiplying the decimal or the fractional part. So again, let's multiply the 0.92 by 6. Okay, so we shall have 5.52. So you write the integer, the whole part here, the 5, and then continue multiplying with the fractional or the decimal part. So we have 0.52. Okay, then we have, let's continue. 0.52 times 6 is actually 3.12. So we write the whole number part here, the 3, and then continue with multiplying 0.12. So again, so let's try. Let's continue. 0.12 times 6 is equal to 0.72. So this time we have no whole number. Our whole number is 0. The integer is 0. So we write 0 here. Okay. So we'll stop right here. Okay. So actually we could have an infinite number, but we don't like to do that. So let's have an agreement. So we shall only obtain the up to first 4 digits or first 4 decimal parts. Okay. So convert 0.82 base 10. So then read downwards. Take note of the integer. Take note the integer, then you read downwards. So we have 4530. So therefore 0.82 base 10 is actually equal to 0.453 base 6. Okay, 0.453 base 6. So let's have a second example. Okay, Let's have a second example here. Convert 0.75 to base 9. So again, so we have to multiply the 0.75 decimal part to base 9 because we want it to convert it to base 9. So 9 would become our multiplier. So let's see. So we have 0.75 times 9. Okay, it's actually equal to 6.75. 6.75. So you write the whole number here 6, then you continue multiplying with the decimal part. So we have 0.75 here. So of course, 0.75 continued multiplying with 9. So you'll have the same answer, of course, 6.75. Then again, take note of 6, and then continue multiplying with the decimal part. So you have 0.75 times 9, so again 6. So you write the 6 here, then continue multiplying with the decimal part. 0.75 times 6 is equal to 6. So this could be an infinite number. We could go on and on, thousands of 6 here, but then we don't like that, so we'll stop here. I will only require up to first 4 decimal numbers. Okay, only first 4 decimal numbers. So we have to cut. We have to cut it to first 4 decimal numbers. So therefore, 0.75 base 10 is equal to 0.666 base 9. So that would become the answer. Okay. So example number 3, we have 0.55 base 10 to base 16. So we have 0.55 times, so you have to multiply it to the base number that you want it to be converted to. So we have 0.55 times 16 is actually equal to 8.8. So you write the whole number here, 8. Then you continue multiplying with 0.8 and 16. 0.8 times 16. So 0.8. So we have to multiply it by 16. Okay. Oh, sorry. It's only 6. So 0.8 times 16 is actually equal to 12. 12.8. So we take note of we write the 0.8 here, but instead of writing 12, we write C, because in base 16 is a hexadecimal. After 9, the valid symbols for hexadecimal are 0 to 9. After 9, we have A, that's 10, B 11, C 12, D 13, E 14, F 15. Okay, so if you get 12 as an integer, so you write C. Okay, C. So since we have a whole number 12 here, so instead of writing 12, so we write C. Okay, then you take note of the decimal part here, then continue multiplying. So 0.8 times 16, so of course you'll get the same answer, 12.8. So instead of writing 12 again, we write C, because again in hexadecimal, after 9, A is 10, 11 is B, 12 is C, D 13, E 14, F 15. Okay, so again, we take note of the fractional part, 0.8 times 16. So again, you'll get the same answer, 12.8. But instead of writing 12, we will write C. Okay, C for 12. Okay, so again we cut. Okay, we could have infinite C here, but then I will only require up to first four decimal numbers for simplicity. Okay, so therefore, then read downwards, then therefore the 0.55 base 10 is equal to 0.8 CCC base 16. Okay, 0.8 cc base 16. Then example number 4, convert 0.65 base 10 to base 2. So we will multiply 0.65 by 2. Okay, so let's try this. 0.65 by 2 times 2. So we'll have 1.3. So you write 1 integer here, then continue with 0.3. 0.3 here. Okay. Then we have 0.3 multiplied by 2. Okay. So minus 1. 0.3 times 2 is 0. So this should be 0. Please correct. Kindly correct your copies. Then 0.6. So this should be 0.6. Okay. 0.6. So I'm glad I'd be able to proofread my IM. Okay. 0.6 then times 2. It's 1.2, so you write 1 here, but you have to change it to 2. Okay. 0.2 times 2 is that would be 0.4, so we write 0 here. So then read the integers are downwards, so 1 0 1 0. So therefore 0.65 base 10 is actually 0.1010 base 2. Please kindly correct your copies. Okay. Then last, okay, so let's have last. Convert 0.15 to base 8. Okay. Convert 0.15 to base 8. So we have to multiply 0.15 times 8. Then take out the whole number. So we have 1.2. Okay. Then continue multiplying with 0.2. Okay, multiply 0.2 by 8. So we shall have 1.6. So you write 1 here, then continue multiplying with 0.6. So we have 0.6. 0.6 times 8. So we shall have 4.8. So you have an integer of 4 here, and then continue multiplying with the decimal part 0.8 times 8. Okay. Okay, so 0.8 times 8. So we shall have 6. 6.4. 6.4. Okay, but we will only take note of the integer. So we'll cut it to 4 decimal numbers. Okay, so that would be enough for me. So and then read the integers downwards. So we have 1146. Then therefore the 0.15 base 10 is equal to 0.1146 base 8. I hope you get it. Did you? I hope you were able to follow. It would have been much better if you also have a calculator. Okay, you try everything. Then please PM me if you notice if there are any corrections that has to be made. Okay, because I'm not perfect. Okay, so there may be some errors in encoding. Okay. Okay, so I guess I believe that you are all bright students here. So I believe that you understood my lecture. So we're done with base 10 to base n. So now let's proceed to base n to base 10. Okay, base n to base 10. Let's start with the integer parts or the whole number part. Okay, so this time, so to convert from base n to base 10, multiply the least significant bit. So when we say least significant bit, this is the least significant bit. And least significant bit, multiply the least significant bit LSB in n raised to 0. So your exponent would be 0 for LSB. Then multiply the adjacent number to n raised to 1, the next number to n raised to 2, and so forth. So we'll start with the exponent 0, then increment the exponent by 1, or increase the exponent by 1, such that this would become the exponent of this would become 1, exponent of this is 2, 3, 4, so and so forth and so on. Okay, Then take note of the product. Afterward, get the sum of the products. Okay. So let's start. So convert 1. Okay, 10011 base 2 to base 10. Okay, so again, this is LSB. If this is LSB, the least significant bit, then therefore the rightmost number, so this one, would become your MSB, most significant bit. Okay, most significant bit because it has the greater weight or greatest weight, so it has the biggest exponent. Okay. So example here, so multiply the least significant bit in n raised to 0. So what would be your n? So this will be your n, the base number. So 10011 base 2, so your n is 2. Okay. So you multiply the LSB 2. Okay, so this is 1. Okay, 1 times 2 raised to 0. So 1 times n raised to 0. But your n is 2, so this is 1 times 2 raised to 0. And any number with an exponent of 0 is equal to 1. So in effect, you're saying that this is 1 times 1 is equal to 1. Okay, so the answer would be equal to 1. Next, we have okay, so this would be better. Okay, so I have x raised to y here. Okay, the next is 1 times n raised to 1, or 1 times 2 raised to 1. 2 raised to 1 is 2 times 1, so you get an answer of 2. Third digit is 0. 0 times 2 raised to 2. So any number multiplied by 0 is 0. So we have 0 here. Same with the fourth digit. So 0 times 2 raised to 3 is still 0. Okay. Then last, the MSB, or the most significant bit, is 1 times 2 raised to 4. So 2 raised to 4. Okay. 2 raised to 4 is equal to 16. So 1 times 16 is 16. Okay, I hope you get it right. I hope you don't get confused. Okay, so we start with the exponent 0, 1, 2, 3, 4. Okay. So we multiply with n. Your n is 2. Base 2, because the given is 10011 base 2. Okay, so take note of the product. So we have 1, 2, 0, 0, 16, and then you add, you get the sum. So you have a summation here, summation symbol, epsilon. So 1 plus 2 plus 16 is 19 base 10. So therefore 1011 base 2 is actually equal to 19 base 10. Okay, you get it right? Okay, so please don't be confused. Okay, clear your mind. Okay, don't stress out. So the university is doing you something good, with online lectures. Okay, with online class. The university is trying hard to keep you safe, to keep us all safe. The students are safe, the faculty are safe. Okay, let's just be safe. Okay, so because everything will be in vain if we're going to get sick, and who knows what will happen to us. So just be safe. Okay, stay positive, stay focused. Okay, focus on my lectures, please. If you don't get my lectures in the first run, so please watch it again, and then watch it again until you get it right. If you still don't get it, please PM me. Okay, I'm more than willing to answer all your queries. Next, second example. So convert 54362 base 8 to base 10. Okay, so this time our n is 8. Okay. So the LSB is 2, least significant bit. So the 2 here, the exponent of this would become 0. Exponent of this is 1, 2, 3, 4. So therefore the 2 here, we multiply it with 8 raised to 0. Okay, 2 times 8 raised to 0 is 2. Because any number multiplied by any number with an exponent of 0 is 0. Okay, ayan. Let's prove it. So 8 raised to 0. So any number with an exponent of 0 is 1. So in effect, 2 times 1 is 2. Next, 6. Okay, so what is the exponent, the second digit? So 6 times 8 raised to 1. Okay, so 6 times 8 is actually 48. The next is 3 times 8 square. Okay, 8 square is 64 times 3. Okay, so 8 square times 3 is 192. Okay, 192. Next, for 4 digits, so you have 4 times 8 raised to 3. Okay, so that is the weight of this bit. 4 times 8 raised to 3. So let's try. 8 raised to 3 times 4 is 2048. 2048. And last, we have 5 times 8 raised to 4. Okay, 8 raised to 4. Okay, times 5 is 20,480. Now you got all the products here, and then you get the sum. Okay, let's try. 2480 plus 224.8 plus 192 plus 48 plus 2. 22,770 base 10. So therefore, 54,362 base 8 is actually equal to 22,770. Okay? Are you still awake? Okay. Please be in a good mood. Good mood to learn. Okay. Still have fractional part though. And then you're going to have your assignment. So this will be our next assignment 1.2. You have to submit it immediately to me. Okay. Am I done? Oh yeah. wait. Okay, so let's have a third example. Convert 2AB 74 base 16. So this is hexadecimal. So convert 2AB 74 base 16 to base 10. So again, the LSB, or the least significant bit, start off with n raised to 0. Your n is n. Your n is 16 raised to 0. So we always start with n raised to 0. But our n here is 16. Okay, so we multiply the LSB therefore to 16 raised to 0. Okay, so let's try. Let's have our calculator here to prove that for proofreading also, for corrections. Okay, so 4 times 16 raised to 0. So any number multiplied with an exponent of 0 is equal to 1. So 4 times 1 is 4. Then next we have 7 times 16 raised to 1. Okay. 7 times 16 is 112. So we have right here. Okay. B. Okay. What is B? Okay. So since this is a hexadecimal, instead of 410, we have A. 11 is B. 12 is C. D is what? D is 13. E is 14. F is 15. So for B, so it actually has a value of 11 times 16 square. So let's try 16 square times 11. Okay, so we'll have an answer of 2816. Then we have for A, we have A is 10 times 16 cube, 16 raised to 3. So this time our exponent has increment from 2 to 3. Okay, so 16 cube, 16 raised to cube, 16 cube. So we have cube here times 10. Of course, this should give an answer of 4960. And last, we have 2 times 16 raised to the 4th. Okay, so 16 raised to 4. Okay, so use a xy here. 65,536 times 2. We have 2 here. We have to multiply it by 2. So it will give an answer of 131,072. So you have all the products here. So what will you do with this? So you add. Let's add 131,072 plus 4960 plus 2816 plus 112 plus 4 equals 174,964 base 10. So therefore 2AB 74 base 16 is actually equal to 174,964 base 10. Then we have convert 35412 base 4 in base 10. Okay. So again, the LSB starts with the exponent of 0. Okay. So this is our LSB. Okay. So this would become 2 times 4 raised to 0, or 2 times 1 is 2. And then next bit is 1 times 4 raised to 1. So 1 times 4. It should have been 1 times 4. Okay. So we have 1 times 4 is 4. Okay, then 4 times 4 square. Okay, 4 square is 16 times 4. Okay, 4 square times 4 is 64. Okay, and then we have 5 times 4 cube. Okay, 4 cube times 5, 320. And last we have 3 times 4 raised to 4. Okay, 4 raised to 4. 4 raised to 4 is 256 times 3. So we have 768. Then let's add. Okay, plus 320 plus 64 plus 4 plus 2. Okay, so the sum is 1158. Okay, so 1158. 1158. Okay, so therefore 35,412 base 4 is actually 1,158 base 10. Oh, we have more here. More examples. So that means you have to master this conversion. Convert 65,302 base 7 in base 10. So our LSB here is base 2. Okay, with n equal to 7. So n raised to 0. So let's start with n raised to 0. So 2 times 7 raised to 0 is actually equal to 2 times 1, 2. So for the second digit, 0 times 7 raised to 1 is 0. Okay. So 3 times 7 square. Okay, let's check. 7 square times 3 is 147. Then 5 times, what's this? 5 times 7 cube. Okay, 5 times 7 cube, okay, is 1715. And last we have 6 times 7 to the 4th. Okay, 7 to the 4th times 6. 14,406. Then get the sum. Okay, get the sum. Okay. Okay, what's the answer? So we get the same answer. So 16,270 base 10. So the answer is therefore the 65,302 base 7 is actually equal to 16,270 base 10. And last example for this, convert 403 to 1 base 5 to base 10. Okay. So we start with the n raised to 0. Our n here is 5. So 1 times 5 raised to 0 is actually 1 times 1 is 1. 2 times 5 raised to 1 is 2 times 5 is equal to 10. 3 times 5 square. Okay. 5 square is 25 times 3. 75. Okay. Next is 0 times 5 raised to 3 is 0. And last we have 4 times 5 raised to the 4th. Okay. 5 raised to 4 times 4 is 2,500. Then you get the sum. Okay, get the sum. Okay. So we have 2,586. So therefore 40,321 is actually equal to 2,586 base 10. Okay. I hope you're not having info overload. So this is just a review. So I hope your brains are getting warmed up. Okay. Warm up. Okay, so you need a break from ML, from YouTube, from what else? Do you watch Netflix? Kiss Asian? Okay, so you need to warm up. Okay, it's time to fill your brains with something educational. Are you still there? I hope you're not sleeping. Okay, so this will be our last topic. So we have fractional part. Okay, so we have to convert the fractional part from base n to base 10. Multiply starting from most significant bit to n raised to -1. So this time in a fractional part, so we start with n raised to -1. Okay, then multiply the adjacent number to -2, n raised to -2, then next n raised to -3, and so forth. So this time we start with n raised to -1. Okay, but we start with most significant bit. So this is our most significant bit, the one that is right after the dot, 0 point. Okay, 0 point. So that would be our most significant bit. Okay. Okay. We're still multiplying, but we start with the most significant bit. So this time we have given example number 1. Convert 0.4 FA base 16 in base 10. Okay, we'll start with the most significant bit. So this is our most significant bit, 4. Okay, so let's check. Okay, 4 times 16 raised to negative 1. Okay, 16 raised to negative 1. Oh, wait. 16 raised to negative 1. It's not negating. Wait. Why? Uh-huh. 16. Wait. 16. Okay. Raised to. Okay, so that's it. I have to punch number first and then negate. Okay, now we have 16 raised to negative 1. So what would be the answer? Okay, times 4. Times 4. So we have 0.25 here. Okay? 0.25. Next, F is actually 15. Okay, so again, for hexadecimal, instead of 10, we have A, 11B, 12C, D, 13E, 14, F, 15. So we have F here. Okay, in lieu of F, so please punch 15 in your calculator. 15 times 16 to the negative 2. Okay, we start with negative 1. Next is negative 2. Then negative 3. If you have 4 digit, negative 4, negative 5. Okay, so 15 times 16, negative 2. Okay, 16 raised to negative 2. Okay, times 15. Okay, so the answer is 0.0586. So we just round the numbers to the first 4 decimal digits. Okay, so 0.0586. So this is the answer. And then for A here, A is 10. A is 10 times 16 raised to negative 3. So 16 raised to negative 3. Okay, times 10. So we have 0.0024. So 0.0024. Then, okay, we have it. We got it right. Okay. Then you add. You get the summation. You have the epsilon here. Epsilon means you have to add. You have to get the sum. So 0.25 plus 0.0586 plus 0.0024. Okay, so we have sum of 0.311. Okay, so therefore 0.4 FA base 16 is equal to 0.311 base 10. Easy, right? Okay, convert 0.765 base 8 in base 10. So what happened here? It moved. Okay, wait. I think it would have been better if I just move this one. Okay, so the numbers move. I think I have to save this. Okay, so we have 0.765 base 8. So the MSB here is the 7. Okay, so we're going to multiply it to the base number 8 with an exponent of negative 1. This one is times 8 negative 2 and 8 negative 3. So let's start. Okay, let's start. So 7 times 8, 8 raised to negative 1. So 8 raised to negative 1. Okay, times 7. So you have the answer of 0.875. Okay, so we have it. Got it right. So 8 next. 8 raised to negative 2. Okay, times 6. So we have 0.0938. or 0.09375. So we have the same answer here. And then third, we have 5 times 8 to the negative 3. So 8 raised to negative 3. Okay. Times 5. So we have 0.00976. Okay. 0.00976. Or 977. Then you get the sum. Okay. Get the sum. So we have 0.875 plus 0.09375 plus, what's this? 0.00976. Okay. The answer is 0.97851. Okay. So therefore 0.765 base 8 is equal to 0.97851 base 10. Okay, so we're now in example number 3. We still have until example number 6. Okay, so we have 0.323 base 4 to base 10. So again, our MSB here is 3 right after the dot, 0 dot MSB. So the MSB is 3. So multiply it by n raised to negative 1. So our n is 4, and negative 1 and negative 2 and negative 3. So we have multiply it by 3 times 4, negative 1. So 4 negative 1. Okay, times 3. So we have 0.75. Okay. Then next we have 2 times 4 raised to negative 2. So 4 raised to negative 2 times 2. Okay, so we have 0.125, and last we have 3 times 4 raised to negative 3. So 4 raised to negative 3, negative 3, okay, times 3. So we have 0.046875. Okay, then add. Let's add. Plus 0.125 plus 0.75. So the answer is, okay, 0.921875 base 10. So therefore 0.323 base 4 is 0.921875 base 10. Are still there? Wake up, wake up! Wake up! Okay. Convert 0.111 base 2 to base 10. Just hang in there. We'll only have 3 examples left. Then you'll have your second assignment. 0.111 base 2 in base 10. So again, your MSB is right after the dot. So this will be your MSB. So you start multiplying the n with negative 1. So we have, this is 2 negative, our n is base 2. So this one, multiply it by 2 negative 1, 2 raised to negative 1, 2 raised to negative 2, and 2 raised to negative 3. So we have here 1 times 2, negative 1. Okay, 2 raised to negative 1. Times 1 is 0.5. Then the other one is 2 raised to negative 2. 2 raised to negative 2. Okay, 0.25. And then last is 2 raised to negative 3. 2 raised to negative 3. Okay, so we have 0.125. Then you add. Okay, add. Okay, 0.125 plus 0.25 plus, okay, sorry. 0.125. 0.125 plus 0.25. 0.25 plus 0.5. Okay? Oh, wait. Okay. We have to erase. Okay. Again. 0.5 plus 0.25 plus 0.125. It's 0.125. Okay. 1, 2, 3. Okay. 0.875. So the answer is 0.875 base 10. So 0.1111 base 2 is actually equal to 0.875 base 10. Okay. Then we have example number 5. Convert 0.543 in base 10. Okay. So our n is 6. So our MSB is right after the dot. So we have 5 MSB here. So you start 5 multiply the MSB to n negative 1. So this is 6 negative 1 multiply this 6 negative 2 and 6 negative 3. Okay, so we have 5 times 6 to the start with 5 times 6 negative 1. So 6 raised to negative 1. Okay, times 5. Okay, so we have infinite number here, so we will only take note of four decimal digits. So we have 0.8333. Okay, next we have 4 times 6 raised to negative 2. So 6 negative 2. Okay, times 4. So we have 0.1111. Okay, so infinite numbers again, but we will only take note of 4 decimal digits. So we have 6 raised to negative 3. Okay, times 3. So we shall have 0.0138. Okay, 0.0138. Okay, then get the sum. Okay, so we will only let's add. Okay, so this wrong. I should have input I should have entered 0.0138. Okay, let's try again. 0.0138 plus 0.1111 plus 0.83333. Oh, okay. Then the answer is 0.9582. So 0.543 base 6 is actually equal to 0.9582 base 10. And last, hooray! We're now last. Okay. Example number 6 converts point A73 base 12. So we have the decimal base 12 to base 10. Okay. So A is actually equal to 10. Okay, so A is 10. You might get confused here. So yeah, okay. So our MSB is A. Then its weight is 12 raised to negative 1. Then the 7 here, next digit, multiply it by 12 negative 2 and 12 negative 3. So A is actually 10. So 12 raised to negative 1 times 10 is 0.8333. Okay, right. Okay, next we have 7 times 12 negative 2. So this from here, 7 here. So 12 raised to negative 2 times 7 is 0.0486. Okay, so we just round it off to first 4 decimal digits, and then last is 12 raised to negative 3. 12 raised to negative 3 times what's this one? Wait, I think I got it wrong. Wait. Okay, 12 raised to negative 3. 12 raised to negative 3. Okay. Okay, so you have E negative 4 times 3. Okay, so we have 0.0017. So 0.0017. Okay. Okay, same. Then let's add 0.8333 plus 0.0017 0.0486 plus 0.0017, okay, equals 0.883610. So therefore 0.873 base 12 is actually 0.8336 base 10. I hope you please don't get confused, okay? So that's all for now. Okay, so assignment. Please do this assessment number 2 due tomorrow morning. Tomorrow morning until 9 a.m. only. Okay? Okay. I want your answers to be 110. With all the solutions here. You have to show your solutions, and then you take a pictures, and then you send it through MS Teams. Okay, any questions? Okay, just PM me for any questions. Okay, if you don't get it right to the first view, please view it again. Watch it over and over again until you understand. Okay, so that's all for now. Okay, so see you. I hope, guys, we could have a Zoom meeting. I hope you have computers. Does all of you have computers? Okay, so I hope to see you in person. Okay, I want to know how are you doing. Okay, so bye. See you tomorrow.